Okay, so 7E, using pronumerals in place of numbers. That's the title that the textbook gives us. But basically what this last exercise is, we're not doing any new formulas, any new techniques, but we're trying to use the things that we've already learnt in some less familiar situations. Last chance. Keep your mouth closed, please. Or you can sit over here. Okay, first question. A triangle has vertices A, B, and C. Find the coordinates of the midpoint, which we're calling P, of AB, and the midpoint Q of BC. So normally I would call that capital M for midpoint, and I would write a little AB. But that's actually, they're telling me to call it the point P. Okay, I'm calling this point P instead of a midpoint. Now I'm going to be using the A and the B to find the midpoint. So that means that you average the x's. That will be -1 plus -5 over 2. Then you will average the y's, which is -5 plus a 5 over 2. I want to simplify each of those fractions. The first one is -6 over 2, which makes -3. And -5 plus 5 is 0 over 2, so that's just 0. Okay, so the point P is the point -3, 0. Now I want to find my point Q, which is the midpoint of B and C. So I'm doing the same thing again, but I'm just using B. I'm going to highlight C now, those 2 points. Okay, so we'll do the same process. Average the x's. So that's going to be -5 plus 5 over 2. And then average the y's. 5 plus 1 over 2. Working them out, -5 plus 5 is 0, divided by 2 is still 0. 5 plus 1 is 6, over 2 makes 3. Okay, that's it. That's all we have to do. I have found the point P and the point Q. That's all that question asked me to do. Part B of the question, though, says to show that PQ, remember this symbol? Parallel, excellent, is parallel to AC. As soon as you are talking about parallel, it means that you need to do the gradients. So I need to know the gradient of PQ and I need to know the gradient of AC to show that they are equal, because that's what happens with parallel lines. They have equal gradients. So I need to see the points there at the top of the page. The gradient, which is little m, of PQ. Okay, so P and Q, the ones that I just found. To find the gradient, you subtract the y values over, subtract the x values. So the y values first. 3 minus 0 over 0 minus minus, which makes a plus, 3. That means 3 on the top and 3 on the bottom, so that does just equal the gradient of 1. Now let's do the gradient, so m again, of A and C. So that's using the points right up at the top of the page. I'll highlight them for you. So A and C is already highlighted. So we do subtract the y values. That will be 1 minus minus, so plus 5, over x values. 5 minus minus, so plus 1. 6 on the top, 6 on the bottom, which means that is equal to 1 as well. So I have shown that the gradient of PQ is equal to the gradient of AC, which means that PQ is parallel to AC. Okay, done that part, but there's more to that question. Show PQ is parallel to AC and that PQ equals half AC. The PQ in here, that's not talking about the gradient anymore. That is talking about a distance. Okay, when it said parallel, I knew I needed gradients, but normally when I have two letters like that, it's talking about the distance between those 2 points. So I want to show that the distance PQ is equal to half the distance of AC. Distance formula time. So hopefully you've got enough room there. We've got a bit more to do here. So PQ, using the distance formula, we have a big square root sign. Now our P and our Q, right up there at the top of the page, the distance formula is x2 take x1 in brackets squared, right? So you want the x values, you want to subtract them. That's going to be, where is it? P and Q, 0 minus minus, so plus 3, close bracket squared. Then plus, we want to do the same thing with the y values. So that will be 3 take away 0, close bracket squared. Now, most of the time, it's best if you leave these things in exact form, okay? So 3 squared is 9, and then another 3 squared is 9. So that is equal to 9 plus 9 is 18, square root of 18. Or you just type everything underneath the square root sign into your calculator, and that will give you the answer.
3 root 2.
But yes, we're going to simplify the surd. So 18 is the same as 9 times 2. So 9 is a perfect square, which means that we can simplify that to 3 square root 2. I also need to find the distance AC. So distance formula again, using the A and C, the ones in blue at the top of the page. First of all, we subtract the x values. So that's going to be 5 take away minus 1, so become a plus 1 squared. Then plus, subtract the y values. Y minus minus 5, so plus 5 squared. So that's 6 squared plus 6 squared, which is 72. To simplify that surd, you could do 36 times 2, right? The biggest perfect square you could bring out of that is 36. So it goes square root of 36 times square root of 2, which makes 6 root 2. Okay, so I need to show the PQ equals half AC thing. All right, so AC, I'm going to change colour here. There we go. AC is equal to, it's the 6 root 2. Instead, I could write that as 2 lots of 3 root 2, right? Because 2 times 3 makes 6, okay? But by doing that, the 3 root 2 is the distance PQ, isn't it? So I can go AC is equal to 2 lots of PQ, or the way they had it in the question, they had the PQ by itself. So I get the PQ by itself by dividing by 2. Now that can be AC over 2 or half of AC, which is how they wrote it in the question. Good. All right. Next page. Question 2. A triangle has vertices A, B, and C, but you'll notice in those points there that they're not numbers or just numbers in those points. We've got some pronumerals in here. Okay, so we need to find the coordinates of the midpoint, which we're calling P, of A, B, and the midpoint Q of BC. That's very similar to what we did in question 1, but these points just aren't as nice as the ones that I used in question 1, but we know how to do it. So P is the midpoint of A and B. Okay, so using the midpoint formula, I'm using point A and point B. The midpoint is averaging the x's, so that's going to be 2A plus 2B over 2, comma, then we average the y's, so that's 0 plus 2C over 2. Now, because the first one here has 2a, 2b over 2, we could cancel the 2 out of everything. So that would just be equal to a plus b for the x-coordinate. The y-coordinate, 0 plus 2c, I don't really need the 0, and the 2 on the top and the 2 on the bottom will cancel out. So the y-coordinate is equal to c. Okay, that's as good as we can get for now for our point P. Now we want to do the same thing to find Q. So Q is the midpoint of B and C. So I'm now going to do B and C, these two up here, midpoint formula. Just like before, we average the x's. So that's 2b plus 0 over 2. Then we average the y's. So that's 2c plus 0 over 2. Now the plus zeros don't do anything. So 2b over 2, the 2's will cancel out, and I will just get b for my x-coordinate. And same thing happens for the y value. The 2's will cancel out again, and I get the point C for the y value. Okay, that's part A done. Now, here comes, it's the same stuff again. We want to show that PQ is parallel to AC. So we know what to do. We have to find the gradients of both of those things. Make sure you write small so you've got enough room in there. Shrink it down so you can see the whole lot. So I need the gradient, little m, of PQ. So P and Q, they're the ones that I just found. To find the gradient, we subtract the y values. So that's C minus C over, subtract the x values. B minus, now that would be need to minus the A plus the B. You would need to expand that minus through. However, because the top, C minus C, because that's 0, it actually really doesn't matter what's down here. 0 divided by anything is 0. So the gradient of that is just equal to 0. 0 divided by anything is always 0. Let's do the other one. Gradient of A and C. They are up the top of the page, blue highlighted ones. So A and C. That will be subtracting the y values, 0 minus 0. We know what's going to happen here already. 0 minus 0, let's just finish it though. Over, subtracting the x's, 0 minus 2a. You do need to make sure that your denominator is not 0, okay, because you can't have 0 on the bottom of a fraction, otherwise it's an error, can't divide that. So we have 0 on the top, but we do have something on the bottom, so that would be equal to 0. So both of them have a gradient of 0, which means that they are parallel. Same gradient means parallel. So therefore, PQ is parallel to AC. Now we need to do our distance formula trick. We're trying to show that PQ is equal to half AC again. So I need distance of PQ and distance of AC. So let's do each of those. Distance, can I see them up there? Yes. Distance is equal to, this is of PQ, big square root sign. We subtract the x's. So that's going to be, I'm going to do the a plus b first because it's nicer. A plus b minus b, because it doesn't matter as long as you start with the same one each time. So I'm going to start with this point because it subtracts nicer, that's all. So that x value minus that x value, then c minus c, subtracting the y values. So plus c minus c in brackets squared. So in here, a plus b minus b, the b's will cancel out, and I have just got a in that bracket, and that's squared, so that's a squared. The second bracket, c minus c, is 0. 0 squared is still 0, so that's all I've got. I've got the square root of a squared, but a square root undoes a squared, so that is just equal to a. Comes out nicely, doesn't it? Let's see if the other one comes out nicely as well. So we now want the distance AC. So AC, my blue ones, subtracting my x values. It's going to be nicer if I do this one first. So I'm going to do 2a minus 0 in brackets squared plus 0 minus 0 brackets squared. The 2a minus 0 is just 2a. When you square that, you have to square the 2, which becomes a 4a squared. The second bracket obviously doesn't do anything. 0 minus 0 is nothing. And so now I want to square root 4a squared, which means you square root the number and you square root the a squared, and we're back down to 2a again. So now we just need to do our little show. We want to show that PQ is equal to half AC. So if we start with our AC, like I did last time, that is equal to 2 times by the A, right? 2A. But the A is equal to the distance PQ, or PQ. So I'm going to write AC is equal to 2PQ, because A is PQ. And like last time, divide the 2 away. So that's half AC. Okay? So that's the letters part of it, trying to do those showing things at the end and having a lot more letters in the points that you're using.